so cold today.
It's not cold. I haven't seen any frost on my car yet. I mean, so it's not cold.
Just a matter of time.
All right, so now that we are recording, and I think it's recording from the right channel. Yep, it is. Let's go ahead and take a look at the Raspberry Pi. This is the home page of Raspberry Pi, and obviously they got T-shirts. Let's go ahead and take a look at the quick start guide. What it is a Linux platform. It's a hardware. It's both hardware and software, but you're paying mostly for the hardware because the software is open sourced and therefore it is free. And this is the hardware of the Raspberry Pi, just from the block perspective. That's basically what it is. You have a processor, a ARM-based processor. You have HDMI as an interface to hook up to your HD TV and stuff like that. You have LAN. This is an Ethernet connection, so you can hook it up to a wired networking system. You have USB. I think according to this picture, it has 2 ports. I think has a bunch of LEDs, has indicators, has a speaker port, RCA video port, which is probably for older TVs, NTSC type of TV. GPIO stands for General Purpose I/O, input output, and then the processor is has 256 megabytes of RAM built into it, and then you have your power adapter, and it can also take on an SD card for expanded storage, so you can store stuff onto your SD card. And here it says you will need an SD card with an operating system preloaded so you can boot the Raspberry Pi. In other words, the SD card slot is replacing the hard drive of a regular computer. So the question now is, according to this picture is actually to scale. How big do you think the Raspberry Pi is?
Pretty small.
It's tiny, okay? It's tiny, and the power consumption is, well, it says right here that in order to give it a power supply, you have to give it at least 5 volts at 700 milliamp. That basically multiplies to 3.5 watts. Some flashlights, would produce more power than this entire computer takes. And I'm not talking about, a baton-sized, flashlight. I'm talking about flashlights that you can put in your pocket, LED flashlights. So it's, in terms of power consumption, it's not really that bad. But the best part of this is you can use it you can flash SD card from Linux or Windows PC. So you can set it up, pretty easily, regardless of what platform you're using to get to this page. But the point is, you can run Linux on a small computer like this. Now, why would you want to run a computer? Let me see if they have pictures about this. So they got the setup, store. I guess they might have some pictures in the store.
How much is something like that? Said how much is
$25, I think.
There were pictures on the Google search.
Sorry?
There were pictures on the Google search.
Okay, yeah, I saw that too. Yep, there are pictures here. And depending on where you buy it, you can get it for different prices. So let's see, there was one place I found, with 512, probably stands for 512 megabytes. So let's go to this Newark website. Newark is a website, for ordering electronic parts. Occasionally, they also carry stuff that is already built like this. That's the full size of a Raspberry Pi. You can see the scale of the whole thing. This is your USB connector. So you can kind of imagine the size of the overall controller. And if you look at the price here, the price is $35 if you buy one. And what are you going to do with this? Okay, so you can buy something like this for $35. All you need is a micro USB power supply. Just about the same thing that you use to charge a phone and your other USB devices. So what are you going to do with this? Other than just telling your friends, hey, I got a Raspberry Pi.
It's a little computer, isn't it?
It's basically a standalone computer that can run Linux. Okay, Now, I wouldn't say it can run, the full-blown Linux. In other words, with 256 megabytes of RAM or even 512, you can run a GUI, but not, anything that is too elaborate. What can you do? It's the form factor that is important. So with this type of form factor being tiny and has very little power dissipation, you can put it into what type of applications?
Mostly.
Sorry?
Mobile mostly.
Mobile, okay. Anything that requires mobility, battery powered. You can put it inside a car, for instance. So if you want to replace your car's stereo system with something else, this is $35. Do you think I can use this as a media player? Just for music, not even the video. Do you think it will fit the bill?
Yeah.
$35, do you think that's less expensive or more expensive than a regular car stereo system? It's less expensive. Now, it doesn't include the amp, okay? So that's one thing you have to kind of keep in mind is it has an external jack, for headphones, but not, to power up your, 300-watt bass speakers. So you have to have an amp, with the rest of your system. But it does give you the flexibility of, playing just about anything because, if you can put it into Linux, it can run it. Okay. Are there any other questions about, something like this? How much RAM is 512 megabytes? In other words, what can you possibly run using only 512 megabytes? Well, it depends on the operating system and the applications that you want to run, right? So let's take a look at how much RAM I'm currently using, and I'll even start. Well, let's go ahead and take a look right now. And it doesn't have the
Task manager.
Task Manager should do it. Let's see, preferences. Okay, so right now I'm using only 10% of the memory that I have on this system. And how much RAM do you think I have over here?
2 gigs.
No, this guy has more than 2 gigs. I have 4 gigs of RAM, and it's using 10%, which means it's using 400 megabytes. You can also tell from here, how much RAM I'm using. It tells me it's using 1.4 gigabytes, but of which 900 are used as cache. So this is less than 512 megabytes. I'm using practically less than 512 megabytes, and yet I'm running a browser, the full operating system, doing screen recording all at the same time. Okay. So with a Raspberry Pi, you can do pretty much the same thing, except it will be a bit slower because the processor is a slower processor. It's kind of the same type of processor that you have on the cell phone. So it's not going to be nearly as fast as a processor that is in this box here. But at the same time, you also don't need any cooling fans. It's a very small package. You can put it inside a metallic box with no or very little ventilation, and it will still work fine. What else do you think you can put? What can you do with this and make it useful? You can make a computer, right? You can make a computer out of this thing. Put it inside the box, and and basically run anything that will fit inside something like this. What about robots? Do you think this might be useful for robotics?
Yeah.
Okay. Well, the fact that it has no moving parts, no hard drive, and stuff like that, means that vibration should not be a big issue, like when you have a hard drive inside a laptop computer. And $35 is, well, it's some money, but it's not like a lot of money. I mean, 10 Starbucks, how much is Starbucks now? A medium coffee. $5. So 7 times going to Starbucks is already a Raspberry Pi. Okay, so it's not bad. And I think the best part of it is you can just kind of play with it, experiment with it, and use it in different applications. Any questions about this? And do you have any plans? Since you have one already, do you have any plans of what to do with it?
Oh, I don't have one.
Oh, you don't have it yet.
But
Okay.
people
Now-
are messing around
I think there's a lot of possibilities. It has a USB port here. So the question is, what do you think, you can, what kind of USB devices do you think will work with this little board running Linux? just about anything that I can use using my own Linux distribution. And the answer is that it's because Linux is ported to multiple platforms, but it's still basically the same software. In other words, if I have a particular driver for this microphone, on using my own distribution like this one, if I run Linux on this particular platform, it's the same thing. So whatever is supported, when I run Linux using a desktop computer, is going to be supported device-wise, with a platform like that, which is a big plus because now you can say, okay, I can play with a device, an external USB device using a desktop or a laptop computer. Once I figure out how to use it and that it works, you can make it work with this one too. Yep.
They have versions of Linux that are compiled for ARM processors?
Yeah. Yeah, there are multiple. It depends on the platform that you want to use. If you go to, this is only one example. I'm not saying that Debian is the only distribution that supports ARM. But if you want a quick and easy way to, get ARM support for Linux, this is one because you can go to their. I'll just go ahead and look up one package here. I'll just look up the screen recording software that I'm using. Okay, FFmpeg. I want to look up packages, search FFmpeg, which is a very common package. It's just for converting between multimedia formats. And we'll just look for the stable release of it. And this is a list of the platforms that it is currently supporting. You can see that it supports i386, which is the 32-bit Intel processor. Most of us can use that. IA64 is the 64-bit version of the Intel platform. You can also see ARM EL here, and also AMD64. I take it back. AMD64 is what you want to use if you want to turn your computer into 64-bit. The IA64 is for a really old and kind of obsolete architecture that Intel started off with, but later on they changed to the AMD instruction set because it is more efficient. It also supports the PowerPC. The PowerPC is still used. It's just not used on Macs anymore. Basically, Apple stopped using the PowerPC a little bit of time ago in favor of the Intel architecture. But the PowerPC is used on what type of architecture? We talked about this, in the class as well, but I didn't name the processor architecture. PlayStation. Okay. A PS3 uses PowerPC as its main processor. The 16 cores are all basically PowerPCs. The S390 is a IBM mainframe processor, so you can actually run Linux using, you can use Linux on one of those older IBM mainframe computers. Spark is used by Sun Microsystems, now Oracle. But you can see that ARM is also supported. In other words, there's a package for the Raspberry Pi. This particular package will run on the Raspberry Pi. Okay. Any other questions about this? No questions? Okay. Now, for a smaller device like that, what you can also do is you can make your own IP camera easily. What is an IP camera? What are the components of an IP camera? How can you make your own IP camera?
You need the camera itself.
Sorry?
You need the camera itself.
Okay. So let's take a look at IP camera. I know we are kind of digressing from the systems analysis, topic, but I think this is a lot more fun. Okay, so IP stands for Internet Protocol. Okay, that's what IP stands for, which also means it's basically a networked computer, a networked camera. So now we have Raspberry Pi in the middle here, because I'm trying to use a Raspberry Pi. We have a USB port, okay, or once you have one USB port, you can hook it up to a USB hub and expand the number of connections. Now they will still be sharing, the same speed of one single USB port, but you'll be able to connect multiple devices to one single USB port on the board itself. Okay, so and then we have, just from the USB we can do a few things. Okay. Well, one thing you can do is to hook it up to a webcam. right? Because a webcam is already, most of the webcams are USB based, so it connects readily to the USB port. Webcams are well supported by Linux, because most of them use the same chipset. So once you have support for one chipset, it doesn't depend on the brand anymore, because it's just basically repackaging, and different brands specify different plastics, lenses, and all the other peripherals. But as far as the computer is concerned, it's still the same support because it is the same chipset inside the webcams. What if you don't want to use a webcam? Because webcams tend to have kind of crappy lenses, and it's not very sensitive to light. Well, what you can do is to hook it up to a AV audio video digitizer. And these things are not expensive anymore. One of these things can hook up to multiple actual cameras. So you can use this one to hook up to an actual closed circuit camera. Closed circuit camera. And you can get Sony, ones with a Sony sensor, and they have a pretty good sensitivity. I tried one with I tried one that is advertising to have a 0.003 lux sensitivity. You can actually see out there pretty good at night, even without any additional illumination. And the thing about these cameras is, they're very sensitive to infrared illumination. Okay, if you get one of those IR light, any type of IR light, you can basically light up an entire backyard, to the cameras from the camera perspective, but not to any other perspective. So you cannot see any light. Anybody who's walking into your backyard or front yard will think that there's no light is on, but to the camera, it's almost like daylight. So it's really cool. So this gives you the option, if you go through an AV digitizer, it gives you the option of using higher end cameras with better sensors, and you can choose the lens and stuff like that. Okay, so now we can get everything through USB back to the Raspberry Pi. So the Raspberry Pi can take all of that information, do some processing, and as a webcam, what do you think it has to, what is the output of a web, not a webcam, but a IP camera? What is the output? Through a network cable or Wi-Fi. Okay, so over here I'll just kind of separate this into two possible ways to hook up back to the network. One is Wi-Fi, and one is a wired local area network. What can an IP camera usually do? When you go to a store, like Fry's, and you go to the IP camera section, you look up the specs. What can a IP camera usually do? It's a mini web server. Okay? In other words, you can log in to a IP camera and actually see what the cameras are actually seeing. Okay? So now the question is, can I install a web server program into something like a Raspberry Pi? And the answer is yes. Okay, you can then install Apache or something that's even smaller onto a platform like this, and it can become its own basically web server. Can we do motion detection? The answer is absolutely yes. Okay, there's one application program, I cannot remember the name of it, but it allows you to go through a web interface, and you can look through the cameras, and you can define different areas and set up the different areas to motion sensitivity. In other words, if the camera sees any type of motion within those areas, it can automatically trip some sort of event, and then it can start to record like a clip. It can start recording like 10 seconds before the action, and then it will last 10 seconds after the action, and then it can send the clip to you by your phone, by email, or it can upload it to another FTP server and stuff like that. So basically, you have a lot of options to do it. Let me just look it up since we're already here. I think it's open source surveillance software. I'm not going to go into it to talk about it, but there will be. You guys can look into it yourself too. Yep, the name is called Zoneminder. I'm not going to talk about it too much, because it's not the focus of this class. But you can install Zoneminder onto a Raspberry Pi, hook it up to external cameras, and turn it into your own IP camera. And you can customize the whole thing. And the best thing is it doesn't draw that much power. It's just a USB power source, and that's basically all you need. Zoneminder is web-based. In other words, you don't need a custom user interface. All you need is to run the web server on the Raspberry Pi, set up the software. They can log in, through a web interface to the Zoneminder software configuration screen, and then you can set up everything else using a web interface, just a browser from your end. Any questions about this? So there's a lot of possibility. I mean, something like this, I can teach probably multiple classes making use of a platform like this. Now you can argue and say, but I can do everything like this on a PC. And absolutely you're right. You can do everything that I just talked about on a PC. The question is, can you hide a PC between wall panels? Probably not, right? And your PC draws a lot more power too. If you want to set up something like this, let's say in your car, you just bought a $140,000 car, and you want to make sure that nobody comes close to your car. Okay, you can install something like this in your car because it doesn't draw that much current. Okay, and since you have a $140,000 car, it's not too much to ask to have a constant 4G connection. So now your car can send you an email to notify you and say somebody is within 5 feet of your car, and ask you what to do, right? Should it activate the automatic turret? Yes. Any questions about this? And that's another application, automated paintball turret. Yep.
Well, if it uses like a micro USB charger, right? It's like 5 volts.
Yeah.
So you'd have to get like a dock or like a capacitor to go
Yeah.
between the two.
Yeah, but there are tons of solutions like that already. The power consumption is only 3.5 watts. Okay, so we can do some calculations here. The Raspberry Pi is using only 3.5 watts because the power supply is rated at 700 milliamp, which is 0.7 amp, and you multiply that to the voltage, which is 5 volts, and that gives you the actual power consumed by the device. It's only 3.5 watts. Let's say the camera draws another 5 watts, which is a gross overestimate. Okay, and let's just say that when I add up everything plus all the inefficiency and whatnot, we add up to 10 watts. Okay, the question is, can you find a battery pack that can power up something like this for, let's say, a day? Okay, what is a day? 24 hours. Okay, so we are looking at 10 watts times 24 hours. Okay, this is you have to kind of do some conversion here, but this type of energy, when you multiply power by time, you get energy as a unit. So the question is, can a small battery be able to supply that much energy so that I can power up a Raspberry Pi plus the camera plus all the other peripherals for a day? That's the question. Now this, when you multiply this, this is a watt hour, so we have 240 watt hour as the amount of energy that we need here. How do you rate car batteries? Now one way to rate it is called the CCA, or the cold cranking amp. But there's another way to rate batteries is based on also basically watt hours. What is the capacity of a? Okay, let's think about lithium-ion batteries. Most of us know about lithium-ion batteries. I just looked it up. They have rechargeable lithium-ion batteries. And what is the capacity of the ones that are kind of long that people put into flashlights? You guys remember? No?
Talking about double A's or?
Well, let's talk about double A's. Okay. What is the capacity of a double A rechargeable battery? If you just pay like regular money and not too much money, you get about what they call 2 amp hours, which means you can drain it at 1 amp and it will last 2 hours. But the voltage is only 1.2 volts. That's the nominal voltage of a rechargeable battery, a light metal hydride type. So when you look at a single cell, it has 2.4 watt hour because I just multiplied everything together. Now 2.4 is not quite close to 240, but this gives you an idea of how many cells you will need in order to give you 240 watt hours. Basically 100. Okay.
Well, my question is this: if that's rated at 5 volt, right?
Yeah.
And car batteries or car electronic system is 12.
What you need is what they call a DC to DC converter.
Yeah.
So you can convert.
A capacitor.
Yeah, it's not a capacitor. It's actually a pretty complicated circuit in the inside,
Yeah.
but it is. Yeah,
the,
go ahead.
The thing is, like, that amount of power is not going to draw a car battery down, because in between, like, unless you're leaving it for 5 to 6 months, you're not going to draw a car battery away. Especially if you're using something like an Optima battery, which is a gel battery. This totally will last probably 8 to 9 months with that type of power draw.
Yeah, this type of power draw is not. You can actually power this up from your car battery, without any really significant drain to your car's battery.
I think in that particular application, just getting the DC to DC converter is probably way more efficient than just buying a bunch of AA's.
True, but I want to show you, what type of energy we are talking about here. But this is also, remember, this is a gross overestimate of how much power it's going to consume. It's not the actual.
Just 3.5 watts is its maximum, right?
Well, plus you have the camera and possibly IR, the IR illuminator thing. So I'm just over budgeting the power here. But you can power this thing up from the car battery for a day, without any major impact to the car's own battery. Okay, so it's completely feasible. The next question is, can I do the same thing with a laptop computer running the same software for a whole day? The answer is no, because your laptop computer will probably drain enough power from your battery, so by the end of the day you would not be able to crank and start your car anymore.
It's like multiply that 3.5 by 100.
Your laptop computer can probably get it down to maybe 20 watts or so, 15 to 20 watts.
It's not
would
doing
be
anything else.
without doing anything, exactly. Yep. Plus the form factor, and your laptop computer probably needs cooling too, because it has a fan. It needs to extract heat, whereas this guy doesn't need all that stuff. So there's a lot of possibilities with something like that. And once again, I think the important part is not the hardware itself. It's not the $35 hardware. It's the software. Okay, because what can you do with the $35 device? Well, just about anything you can do with any Linux system. That's the answer. You can turn it into a very simple set-top box, because it has an HDMI port already. So if you can install a minimal amount of codec and turn it into a set-top box for recording shows and whatnot. The key is to get a USB-based tuner card, so you can actually watch and record HD TV, over the air broadcast. Then you can also use it to record and encode and compress, all that stuff, at the same time. All right, so that's good to bring up. And the other thing I want to bring up, from the earlier discussion of this class, is the DMCA. And the DMCA, I donated already, but Wiki did not remember, so it's still giving me this, pledge.
You're not logged in.
I really think that people should contribute, whenever they have time to do it, or have the money to do it, because how many people use Wiki on a daily basis? Okay, and we don't have to pay anything, but it still takes money, to run, all those, servers and domain name registration and whatnot. And I think if we just donate $5, and a few bucks, here and there, I think it's for a good cause. That's just me. And it keeps reappearing everywhere.
Yes, top right.
Close. They should have a button like I paid already or donated already.
Using friends' computers.
Using friends' computers. Friends in quotes.
Yeah.
Mm-hmm. It would be kind of interesting if someone sets up a botnet, so that each computer in a botnet will automatically contribute like $2 to Wikipedia. That would be pretty funny. All right, so the Digital Millennium Copyright Act is, let me just show you. It criminalizes production and dissemination of technology, devices, or services intended to circumvent measures, commonly known as DRM, that control access to copyrighted works. It also criminalizes act of circumventing and access control whether or not there is an actual infringement of copyright itself. In other words, okay, this is basically what it is. When you buy a DVD, what are you buying? I asked that question many times in this class, and I think you guys already know the answer. What are you actually buying? Are you buying the physical package with the DVD in the inside, or what? What are you buying?
The right to watch it.
You're buying the license. You're buying the permission to use or view the content under certain restrictions. Okay? All right? So it is already quote-unquote criminal if you play the DVD in public. Okay? So let's say you have a DVD, let's say Home Alone, okay? Really old movie, and nobody cares about that anymore. But nonetheless, if you play that movie in a block party, it's actually technically illegal because you are not supposed to play the video in public. It's for personal viewing only if you are buying the DVD out of a regular store. On the other hand, if you say, yeah, go ahead. I thought you got something to say. Okay, so on the other hand, let's just say that you find that you use the Home Alone DVD a lot, and you think, okay, maybe I should store the DVD onto a hard drive, so that later on, I don't need the DVD anymore. I don't have to risk scratching the DVD, and so it's not playable anymore. And let's just say that in this case, you are not even going to show it in a block party or send it to your friends or do anything other than just viewing the content yourself at home. The act of decrypting the DVD and putting that into your own hard drive is criminal already, according to the DMCA. It is legal to back it up, okay? The copyright allows you to back up the DVD. Unfortunately, to decrypt the DVD in order to back it up is illegal.
There's no way to back it up with that.
You could back up the ISO. Back it up as an ISO.
Yeah, but in order to back up the ISO, you still need to decrypt it first. You cannot back up the ISO without decrypting it first.
It's like this big gray area. That's why they started just giving digital copies with every, they just say, their thing is like we have a digital copy, so it's like a selling point. It's technically
If you ask me, I think that is intentional. The circular reasoning of the DMCA and the fact that in order to back up your DVD, you need to decrypt it first, and the decryption part is the illegal part. I think it was intentional.
Well, because the licensing says that you're allowed to back it up.
Yes.
So they kind of put themselves in a corner by not allowing you to back it up, but saying you can back it up.
Okay. In order to understand the ramifications of this, you can read this page here. It's called a DVD decryptor, which was a software that was written for Windows. And it's a really popular software because not only can you decrypt a DVD and be able to back it up on a hard drive, it also let you select tracks to back up. Okay, so you can actually make the backup a lot smaller than the original DVD because you can say, okay, certain tracks are not useful anymore. And then the legality is the funny part. As the DVD decryptor facilitates the removal of copy restrictions, certain uses may be illegal under the US DMCA. So the DMCA is here. Unless making copies which are covered under the fair use doctrine. Fair use includes educational purposes. So when I show you, let's say next time I show you Home Alone in the class, it's actually okay. So even though it's in a public setting, because it's for educational purposes, it's actually okay. It's covered under the fair use doctrine. So the developer announced via the CD Freaks website that he received a cease and desist letter from Macrovision. Now Macrovision is also an interesting company. This is the very same company that came up with a scheme of copy protection for VHS tapes. Does anyone remember those old days, when you try to copy a VHS tape and the copy has just, endless flickering, and then the screen goes bright and then dark and then bright and then dark again? Well, that's the handiwork of Macrovision, okay? Which is also the very same company which came up with the very lame and basically useless encryption scheme for DVDs. Okay. So he later stated it was within his best interest to comply with the letter and stop development of the program. By June 7th, 2005, a mirror site was up which allowed people to download the final version. On November 27th, after Dawn.com, a Finnish website, announced it complied with a letter received from, guess what, Macrovision, demanding that DVD decryptor be taken down from its site. Shortly thereafter, an original unofficial mirror site with no connection to Lightning UK reappeared. Okay. In other words, Macrovision was sending all these different letters to different organizations all over the world. Okay, not only in the United States, to make people stop distributing DVD decryptor. Okay, but there's no way to protect the author because he did not open source the product. Now, if he had open sourced the product, there would be basically no stopping it because it's just the source code that is uploaded. So under United States federal law, making a backup copy of a DVD video or an audio CD by a consumer is legal under fair use protection. So you can do it, from the legal perspective. This provision conflicts with the DMCA prohibition of so-called circumvention measures of copyright protections. So once again, we have the circular reasoning here. So no matter how you look at it, when you back up your own DVD that you buy from a store, it is illegal because of the DMCA. The only way you can do it legally is to go to a country or send your DVD, your original DVD, and a backup hard drive or SD card, whatever you want to do, send it to a country where the DMCA does not apply, have somebody do it over there, and then send it back with the copy already on your SD card. Because in that case, the circumvention of copyright is not done in the jurisdiction where the DMCA is applicable. But you are legal, it is legal for you to own the copy under the fair use clause. Yeah. Does anyone want to buy an island somewhere, so you can be out of the DMCA jurisdiction?
Why not?
Yeah. Or build an island. Why buy an island when you build one?
Yeah.
Person did that. It's
Yep.
a floating island.
Yep, floating island. And that can be dangerous because if the RIA thinks that there's enough reasons, they can tow your island back into U.S. territory and then sue you.
At that point, it's technically
Then you need to hire mercenaries to protect your island.
Yeah.
That can increase the cost of operations a little bit.
Yeah. Trying to get into international waters.
Yep. So in 2010, the Librarian of Congress instituted a DMCA exemption which protects circumvention of CSS protection under circumstances. This exemption will expire, guess what? Next year. If you have any DVDs to back up, do it now. You still got about a month to do it.
Yeah, just over. Or just.
The software is still legally available due to many countries not having such restrictions, but in November 2005, that Macrovision acquired the intellectual property rights to the software. And this is the other piece that is kind of interesting, because once Macrovision acquires the IP, the intellectual property rights to the software, it is no longer a legal issue with circumventing copy protection measures. It is now a copy protection of the software itself, a copyright issue with the software itself, because now it is owned by Macrovision. It is no longer distributed freely. And this is where open source could have helped, because if the author had open sourced the entire product, then nobody can acquire the IP, the intellectual property, and stop its distribution. Okay? So the distribution itself will still be legal. It is the use of the software that can be illegal. Okay, so you can see how this whole thing becomes is a big mess, but it also kind of illustrates how much law is applicable to copyright, copy protection, and stuff like that. in the United States. And remember earlier, I said how some of the counsels or lawyers who used to work for the RIAA are now Supreme Court justices. Well, that kind of explains why some of these things happens. Yep.
You heard about the UN telecommunications conference?
Mm-mm.
Yeah, it's going on right now. They're actually like representatives from Google and Verizon and Microsoft got sent with the U.S. delegation because they were talking about some similar restrictions that are on like the use of the internet in places like China. They're talking about making that like a worldwide standard. The UN, like the UN's like, because and you know this probably, like the UN's kind of like telecommunication standard is kind of what every country that is a member nation of the UN uses. And so like they're trying to, like a few of the delegations want to like institute the same type of government control over the internet that places like China and many Arab states have and stuff like that.
But the easiest way to do that without having to reinvent the wheel is to copy and paste the ones from China.
Yeah.
Because that has to be the most restrictive one, right?
Yeah. And people are freaking out about it.
I think they have some reasons to freak about it.
Yeah. Everything, most things have pros and cons, but that one seems to have a lot of cons in comparison.
Yeah. All right. So, are there any questions related to DVD decryptor? Which is basically it's a showcase of how these laws apply, and how people, different organizations, want to enforce those rules. And the centerpiece of the whole thing is the DMCA, or the Digital Millennium Copyright Act, which is a very restrictive, copyright act, because it is not just doing it for illegal purposes. It's just the attempt to do it is already illegal. If you are caught, using a hex editor, looking into like the dump of a DVD to try to figure out, how it is encrypted, without even your own algorithm to decrypt it, just investigating how it is encrypted is already borderline illegal. Yep. And yet, how do these media companies make money? What do you think? Well, when was the last time you actually bought a DVD from a store? We don't buy DVDs anymore. How do we get our movies?
Online.
We get it from Netflix, we get it from Hulu, we get it from a variety of online sources, legal online sources, right? So how do those people make money? Netflix has a subscription fee. How about cable? What do you think cable companies do to make money?
Charge you
Or
for
Hulu.
Blu-ray. Oh.
But they charge you money, but I think they can actually make money without charging subscribers money, because they have advertisers. Okay, and advertisement makes a lot of money, and that's how NBC and all the other networks can stay afloat. They can still make money. Sorry.
So that's how Comcast makes all the money.
Well, Comcast makes money from the advertisement and also from subscription.
And also from NBC.
And also from NBC.
Yeah.
Yep.
They own NBC.
Well, on the subject of Comcast, did you hear about Google Wire?
Mm-mm.
It's basically Google's attempt to get into the television service.
Oh.
And they're saying that if it goes well, it's going to be upwards of like a gigabyte a second. So.
And Google has a different model of making money. It's not by copyrights or the licensing of the content. It's like you can watch your movie for free as many times as you want to, but we'll just tag along some advertisements.
There'll be advertisements scrolling down the bottom. There'll be advertisements scrolling down the bottom. It's the same thing as like Google Fiber too, like the internet. So.
Yeah, or YouTube. If you watch YouTube, some of the channels have the AdSense capability enabled, and you have to either watch a 15-second or 5-second ad before the actual main video that you want to watch, or a little banner appears at the bottom, advertising things that are quote unquote related to the video, and that's how Google makes money. It doesn't really care that much about whether the content itself is licensed, because that's not how it makes money. So I think we're looking at a very interesting time. I think the next 10 years will prove to be very interesting from the perspective of copyrights and stuff like that. This is not new, okay? Ever since the first person, ever since, the first book was published, there's the issue of copyright, okay? And that's basically what it was, is, because in the old days, you actually have to have someone to manually copy a book, to a blank, pile of paper, right? And that's, how, copyright, started. And because of the way of distributing content has changed so much from the time when we actually have to copy page by page manually, I think the laws will have to kind of morph and change as well. But I'll tell you something else that I did over the weekend. I watched my buddy, the guy who worked for Lawrence Livermore National Lab, play his video game, and I watched probably 5 or 6 hours of that stuff.
With video game.
He was playing Mass Effect.
1 or 2?
Mass Effect 3.
The new one.
Never played that one.
The new one, yes.
Were you watching the charity stream or something?
No, I was sitting behind him.
Oh, there was a charity stream on YouTube, or
But I was thinking, the whole time, the wives were complaining downstairs, because they got, dinners already cooked. The kids were screaming, and things were happening around the house, and we were just glued to our chairs. I was just glued and watching him play, and he was doing like, he was just so absorbed in the game, and I was thinking at the time, it's like, hey, you can make money doing this. Right, just playing the game and streaming it out, or go through some really basic editing, cut out some of the time-consuming stuff, and somebody's going to watch it. And you can tag along advertisements, like, oh, okay, let's get out of the game and do some advertisement, and then we'll come back to the game, and you can make money out of it.
there's already a site that actually does that. It's called Twitch TV.
Twitch TV.
Yeah, and basically, people you can like have your own like Twitch account that's free and you can stream your own videos, but there are actually people that become partners with companies like Razer and SteelSeries and stuff like that, and they make money just by playing the game. And then the charity thing that I was telling you about over the weekend, there was a Mass Effect 3 marathon charity where they were trying to raise $30,000 for Child's Play, which is this charity for needy children. Anyways, so I watched probably about 10 minutes of it because I really hate watching other people play games. But when I was watching it, they were in like hour 12. They raised like $21,000 already.
Wow.
So, and I actually know a guy who does streaming for like World of Warcraft and makes about $5,000 a year just doing it.
I can believe it. I can believe it because it's entertaining just to watch someone else play, especially if that someone plays the game, completely differently from how you play it.
In an interesting fashion.
In an interesting fashion, exactly. They can choose completely different decisions. For a game like Mass Effect, if you make decisions differently, they change the outcome, throughout the trilogy. It's not like just with that one single game. It's the entire trilogy.
One person dies off in the second one, he's not there in the third.
Yep. So so I can definitely think of that. And the game industry is already is bigger than the movie industry. Right now, it's already bigger than the movie industry. And some of you, I think, in this class, may want to get into the gaming industry. And the question now is, which part of the gaming industry do you want to get into? In the good old days, sorry?
Let's say the art side.
The art side?
Yeah, like that.
Well, in the good old days, computer games are mostly technical. In other words, you're given a very weak, tiny little processor with very little resources. So how do you, crank out the best looking graphics, using the limited resources that you have? But the focus has since changed, gradually to, basically it's like a movie production. In a movie production, how much attention is paid to, the technical stuff? There's some. There is, some to CGI and special effects and stuff like that. There's definitely some, money, put into that. But what is the most important part? When people look at a brand new movie, okay, without reading the reviews, there's a story. There's the producer. There are the actors, right? The story arc, the whole thing. The technical stuff is important, because it does finish up the entire thing, whether it breaks it or it can, have some effect on the popularity of a movie, but it's not the main thing, okay? And it's becoming the same thing with games. Yep.
Well, the thing about the technical side, though, is that there are companies that develop engines, so you really don't need to be able unless you're a company that builds your own engine in-house, you really don't need to be able to build an engine to run a game. Like,
that is true.
the engines like Unigine Heaven and stuff like that are way more advanced and already built. So it's
Yes.
more cost effective to just
But
use
there are new
that.
game engines getting built because that guy who was playing Mass Effect, he also had a Skyrim? No.
Skyrim.
Skyrim?
Skyrim.
Yeah, so he has Skyrim installed on the same computer, but he said, his 2-year-old average graphics card, which has no problems with Mass Effect 3, could not keep up with Skyrim at all. He had to turn off 90% of the features in Skyrim just to run barely.
Wow.
It's because Bethesda's engine sucks.
Well, it's also more detailed.
Yeah.
They focus a lot more detail. It's not just texture mapping for the most part. They're actually rendering, tree branches and stuff like that. So when you walk around the tree, or when you walk around even for a distant tree, it's not just the same tree, just from different angles. It actually changes. You're actually seeing the tree from different angles because the branches are actually rendered. It's not a texture map.
Well, that and tessellation just craps all over video cards in general too. I mean,
Sorry?
Tessellation, like
Okay.
when tessellation is like the difference between seeing a mountain and it looking like just a flat surface and it looking like an actual mountain with texture. So when you add, Skyrim has a lot of tessellation in it. So when you add tessellation to a video game, like you're talking about using probably all 2 gigabytes of your video memory and then probably another gigabyte of your RAM itself, just for frame buffering.
Yep. But that means the engine of a game is still important. How do you make the best out of the hardware is still important.
The Skyrim engine is just inefficient. So that's
It is.
the biggest problem. Just inefficient. It uses way too much memory to do something that you could do with half of the memory
Okay.
that it uses for.
So there's some technical work involved, but most of the work with modern computer games is no longer technical. All right, so now we're getting back to some of the more boring stuff. Yep, go ahead.
Roll sheet.
I'm not taking roll anymore because we have gone past the point where I can drop people. So I can kind of imagine half the class would disappear on Thursdays. Like, oh, we don't have to go to class anymore. All right. So I think last time we started to talk about corporate data security. Yep.
Did you ever talk about the Scratch project? You said we were talking about it this time, is why I'm asking.
Oh, sure. You can talk about it first.
Trying to keep you away from that corporate
Right,
data
do it.
security
Do it
stuff.
over December after today.
I'm gonna be honest.
Yep.
Are you going to do a new Scratch assignment after today?
I think I'll do a Scratch project instead of just an assignment.
Or are you going to put it on the site today?
Maybe later today. Yep. Go ahead.
As far as like a video goes, are you gonna put like an assignment sheet with it, like what it requires to, or are you gonna
You mean the final project,
Yeah.
the presentation? Yeah, I'll make a checklist of items, so you guys can get ready for it. You can already think about the content. At least kind of focus on the content first. So do some research on the topic that you want to do. There are many kind of topics you can choose in this class. You can choose something that's kind of boring, like systems analysis. You can also pick on the DMCA, do your own research on the DMCA, and tell the whole class about your findings.
as long as we can like relate it to this class, we can do it.
Sorry?
As long as we can relate it to this class, we can.
Yeah, even stuff that I may not have mentioned, like the Disability Act, how you have to make a website accessible to the deaf, the blind, and everybody else who might have some disabilities. You can use that too. If you have something like that, you might want to send an email to me first, just so that I know for sure what you're going to work on, and I said yes, that's okay, because that's a big topic too. Accessibility is a big topic in terms of a legal issue as well as a technical issue. All right, so let's go back to our homework assignment. Scratch 2. And this time, you can use my old solution as a basis, or you can start from scratch or use your own program as a basis. So what we want to do is to place a limitation of the number of attempts. We want to limit it to 10 tries. If a user cannot get the answer in 10 tries, conclude the game and indicate to the user that he or she should be able to guess the right answer in 7 tries. In other words, our limit of 10 is already leaving some grace margin of 3 attempts. Each time the sprite asks for an input, you need to indicate the trial number starting with 1, and the last try should be number 10. If the user got the right answer before 10 tries, congratulate the user, and you can stop the game. In other words, if the user get the right answer before 10 trials, you should just stop the game. All right, so let's go ahead, and I'll write the entire game from scratch, no pun intended, so I can just kind of focus on the step-by-step process. We got about 18 minutes, so I think we have enough time to do it. All right, so let's go ahead and re-implement this game. Now remember, when I wrote any type of program, I do not start from start. I do not go from start to finish in one single shot. Okay, I usually go like implement the middle part of it first, and then surround the code with something else so it becomes a part of a bigger chunk, and then the bigger chunk becomes a part of an even bigger chunk.
So start with the base program and then work your way.
I work my way up. It's called bottom-up programming instead of top-down programming. Top-down programming works when you have a really big system, but when you're actually working on the code, it is better to work from the bottom up because it's easy to test. Okay. So what we'll do is we'll keep track of, we'll have some variables to keep track of information. We know for sure that we have a variable that we need to remember the number of trials. Okay, number of trials, so we'll just say num trial, or the number of the trial. Okay, so either way is fine. We know that this has to be set to a certain number. The first one is number 1. So we know that at some point we have to set this variable to a value of 1. Okay, we don't quite know how it fits yet. Okay, but I'm putting all the pieces up first, and then we'll figure out how to connect these pieces. We also know that in logs, or excuse me, in sensing, we have to ask the user to input a guess for trial number block. Remember last time we kind of talked about this already. How do we integrate something that we type, like this is trial number, and then the value from a variable, and then the rest maybe just type also. You guys remember we used the operator called join. Okay. So we'll go ahead and go to operators, and basically drag join into it a few times. So 1, 2, okay. And I think that may be enough already. Let me just go back to my own homework assignment and check it. Okay, so indicate the trial number starting with 1 and the last one is 10.
I think you only need join once.
Okay. Okay, what is your guess? This is trial. Okay, so instead of hello world, I'm going to go to variables, drag num trial here, and I can finish the sentence with something else. Yep.
If it didn't say trial number and I just kept it at the bottom, or various screens, that's fine.
I have to see
it
how
shows it on there.
It
but
shows
it's not
it?
him saying.
Okay. I have to see whether it is consistent with the instruction of the homework assignment. Okay. This is trial, and I'll just put a period here. Okay. So with only this, I can click it already and see whether it is going to give me the right output, and it does. Okay. It tells me, what is your guess? This is trial, 0, and with a period after that. So I probably could have gone with just one single join instead of 2, but but it does work. Click OK. Okay, that's the center part of this, because after this I have the answer, and then I can compare the answer to the actual number that the user has to guess. So that's another variable that I have to make, because I have to remember what is the actual answer. So we'll call that solution. I think that was the name that we picked last time. Okay, so solution is something that we also have to initialize earlier, and we have to set it to a random number. So set solution to, we have to pick a random number from 1 to, if I remember correctly, 1 to 100, like that. And then what do we have to do is we have to kind of, based on the answer, we have to indicate which way it has to go. Do you guys still remember this part? So after this, after asking, I'm going to make myself another variable. I'll call this one guess, which is basically just the number that the user input. And I'll use a set guess to answer from the question, like that. So from here, this is old stuff, by the way. We have most of this stuff from the previous program, minus number of trials. So in this case, I'm just making a new variable so that the name of the variable indicates what it is for. So it's basically just easier to deal with it this way. Now, once I have the answer and I have the solution, now I can start to figure out, okay, what kind of message I should output? So I go to control here, because I know that sometimes I have to tell the user it is too small, other times I can tell the user it's too big. So I'm going to drag and drop a few things here. Let's see. Okay, so I'll make it like this. The first one is going to say, it is too small. Okay, so I put a too small here, or less than operator. The second one will use a greater than operator. And what they're comparing is just the answer. Oops, take it back. In both cases, it's comparing the guess, which is the answer from the question, to the solution. That. And depending on which one I go, I'm going to say different things. So the first one, I'm just going to say, your guess is less than the solution, which is exactly what the comparison indicates. And then the second one, I can just duplicate this, stash it here. Instead of less than, it is now greater than. So this part is basically just copied from the previous program. There's nothing I have to do in else. I can probably just say yes, good job and whatnot, but I can do that after the loop too. So I don't really need to do anything right there. Yep.
Couldn't you also just do 2 if statements?
You can do 2 if statements. You mean sequential and not one within the other one?
Right.
You can do that, but it's preferred. This is the preferred way. This is the preferred way because it indicates how the choices or how the conditions relate to each other. Because if a guess is already less than solution, there's no way it can be greater than the solution at the same time. In other words, even though it works the same way, this is a better structure because for one thing, it is slightly more optimal because you are not performing a comparison that does not need to be done. But more importantly, it also makes sure that you can only catch one or the other. There's no way both can be true. So I would pick it this way, just because of that.
Could you also done like Jockey said, but put in 2 ifs on the first if and then else?
Yes.
Because I did mine like hella different.
Yes, this one can be just an if, doesn't need an else because I have nothing to specify for the else.
Although the else could just do the.
You got it.
Yeah,
Right?
you got it because.
You can do it that way
need to
too.
make the comparison because if it's
Yep.
either of those, then I think.
Yeah, there are different ways to structure the program. I mean, you can certainly put the correct one here. So you got the right answer. Okay, you can put it here too. Okay, so the next question is, how do I put this into a loop so it keeps asking the same question over and over again? The answer is we go to control, and then we use repeat until, and then we stash the entire block here into the body of the loop. So now we have a repeat until loop, and we're just going to do this over and over again. Now, if I do it like this, it would just be an infinite loop, and that's not what I want. I do want to get out of this loop at some point. But now there are 2 reasons to get out of the loop. The first reason to get out of the loop is when the correct answer is, the user put in the correct answer. The second reason to get out of the loop is when number of trials is bumped up to 10 or more. Then we also have to get out. In other words, if I just think about the reasons to get out of the loop, I have 2 reasons now. Now, when I have 2 reasons to get out of the loop and either one would get me out, I need an or instead of an and, right? Because I'm getting out, because of this reason or the other one. The first one will just be, getting out because I got the right answer. So in that case, it is also a comparison. And it is really just saying that the guess, which is what the user input, is the same as the solution. Then I can get out already. The second reason to get out is based on num trial. So, oh, by the way, I forgot about something here, didn't I? In the loop, I should have done something in addition to what I have done already.
You need to add one to each time, one to the number of trials each time.
Yep, I need to add one to the number of trials.
Each time you get it encrypted.
Yep. So I can just say, go to change something by one. And there are different ways to do this too. You can put it, that's the wrong place. I can put it here, and I can change number trial by one, for each iteration. Now that gives me a reason to get out, for the second reason to get out, because now I can say, go to operators again, and I can say, I can use either greater than or less than because they are just kind of symmetric. I can now say if num trial is more than 10, because number 10 is the last one that I should be using, then I want to get out of the loop as well. Yep.
When I did that on mine, it would actually stop at a temp 9. It would get out of the loop at a temp 9. So I increased it to when the number of trials is greater than 11. And then it would actually come out at the 10th trial instead of the 9th trial.
Yeah, I think I had a similar thing. So it does the opposite.
It checks the condition before it gets into the code. So we'll give it a try first. Okay? We can fix problems later on. The next question is, where are we going to put the code to say, hey, you are supposed to be able to get to it in 7 tries. I gave you 10, and yet you still cannot do it. Where do we put it?
If, add another.
At the bottom.
We need another conditional statement, right? Because if I just, put up that message, okay, if I just go to looks and say over here and say, you should be able to get the answer in 7 tries. This is unconditional, which means even if the user get the right answer, it will still, generate this message, which is not what we want. So we want to protect it with a conditional statement. So once again, I'm going to use a conditional statement here. If it's an if then else. The condition in this case, what should I use as the condition?
Answer equals number. Answer equals the number or the solution.
That is correct. Yep. I'm going to use the answer versus the guess, as the solution versus guess as the indicator. I'm not going to use num trial here because I'm bumping up the number of trial by 1, even if the answer is right. So that means if the user gets the right answer in trial number 10, if I compare based on number trial here, it will still give this message to the end user. So that's why I'm going to replicate exactly the same condition here. Just replicate this one, stash it here. But in this case, I will have to move this to the else, right?
Could use a not.
Or put a not in front of it. Either way is fine. You have to flip the logic basically. All right. And there's one more thing to do because the first time I get here, the variable guess is going to be uninitialized. Now, if it is uninitialized, it's always just starting with a particular value. But I want it to be more predictable, so I'm just going to set it to 0 because the solution is from 1 to 100. If I set guess to 0, it should never match the first time.
But shouldn't it be 1 now? Shouldn't it be 1? Just because when we first attempt now, it's going to be in the beginning before we add 1.
There's a possibility if you set it.
That's why yours didn't work because it was 0 before it.
No, I think it's referring to the number of trials.
Right.
Yeah. All right. Well, let's give this a try first and see whether it works. And put the bottom part. It's not strictly required here, but it's just a good idea to put it there. All right. So we'll go ahead and run the game. And I'm going to intentionally, make it, not work for 10 tries. So I'll put 0, 0, 2, 3, 4, 5, 6, This is the critical one because it did ask me for trial number 10, and if I put in the wrong answer in trial number 10, then it will tell me you should be able to get to the right answer in 7 tries, and the game stops. So in terms of that behavior, it is doing it correctly. So now I'm going to run it again, but I will change the program just a little bit. So it doesn't wait for as long. So I'm going to change this to 1 second, 1 second. Okay, and I run the program again. And this time I'm going to get the right answer, but only at trial number 10. Okay, just to make sure that the program is going to give me the right answer when we got it right, but only in the very last try. Okay, so we're going to do the same thing here. 1, 2.
I think you can just hit enter all the time and it just.
Yeah.
I don't know why it does that.
That means your input is empty, which will never match a number. 7.
Yeah, but now when you don't give an answer, it's giving you got the right answer. Because you're not giving an answer, so your if
Oh,
else.
because the else?
The else, that's why I didn't think that using else was a good idea.
Okay, this is number 10, so I'm going to input the right number this time, and it should tell me that good job, you got the right number, you got the right answer, and get out of the loop. Okay, so we have one little thing to fix here because it tells me you got the right answer. When the guess is less than, or when it's not less than, it's not greater than the solution.
Yeah, not equal.
Well,
Unless you put something that.
Tag. This is why I didn't use if else, because there is a way that you can fool the program. Because it's not, if you don't give an answer, it doesn't have to do either check. So then it can just go directly to your else statement.
right.
So.
Or I can do it this way.
Yeah.
I don't give any type of output as far as the whole game is concerned until I'm out of the loop. So this becomes empty. You can stick something over there, like
Yeah, that's the thing, like sticking something in that particular else hierarchy is what you would get that input if you give no answer.
Well, I can stick something right here. I got 1 minute, so I can do a quote unquote error check in here. So I'm gonna put in another conditional statement here. And the conditional statement here is, I can only get here if the guess is not less than and yet not greater than the solution, right?
Yeah.
So if I go to operators and specify a not and an equal, and then put guess, and solution here. Now that's really odd looking because this is saying that the relationship between guess and solution is not less than, it's not greater than, and yet it's not equal to, right? Which will catch the invalid input case. Okay, so I'm going to put something here that will reflect that. I'll say hello,
That's not right.
and just say that you input something invalid. You just wasted a trial. Yay! Right?
Serious.
All right, so let's give it a try and make sure that it's behaving the way it's supposed to. Just press the enter key. You input something invalid, so it worked.
Typing in like letters.
Yep. Okay, so gibberish. Yep. See, it's nice, huh?
What about -1?
-1 is still a number, so it will still say less than. But anything that's other than a number, it cannot compare to a number, and therefore it is not less than, it's not greater than, and yet not equal to.
Did you specify to pick a number if you wanted a number?
Yes. Set variable to.
In the homework,
No, like
it does.
when he asked, select the number.
No, I did not. I just
I just thought of
Everybody else asked their questions first.
Okay, go ahead.
So